Okay, we are going to go over the homework from last night, combining like terms. Remember that to combine like terms, then they have to have the same variable and the same exponent. All right, let's take problem number 1. We have 8y minus 7y minus 2. Okay, we're going to take our first term, which is 8y, and we're going to look at the rest of our expression and see that minus 7y is a like term. So we're going to look at the coefficients. 8y minus 7y is going to give us 1y, but we write that as y. When we have 1 as the coefficient, we just leave that 1 off. And then we have minus 2, and it does not have a like term. This is a constant that does not have another constant, so we can just bring it down, minus 2. So our final answer for combining this is y minus 2. That's as far as we can take it. All right, problem number 2. We have 5q minus q. Think about this q and think about what the coefficient is. The coefficient would be 1. There's an imaginary 1 right there. So 5q minus 1q would be 4q. And that would be our final answer. Problem number 3. We have some parentheses in this expression, and order of operations tell us that we have to do the parentheses first. So we can't combine what is in parentheses because it's not like terms. But this 2 outside of the parentheses tells us that we need to multiply 2 times everything that's inside of the parentheses. And we're going to be using the distributive property. So 2 times 8d squared gives us 16d squared. And we're going to bring down the same sign, minus, and we're going to then distribute our 2 to the 5. So 2 times 5 gives us 10. And then we've got to bring down the rest of our expression, minus 3d squared. Okay, so now our new expression is 16d squared minus 10 minus 3d squared. So we're going to take our first term, which is 16d squared, and we'll look at the rest of our expression and see that minus 3d squared is the same. It has the same variable with the same exponent. So 16d squared minus 3d squared gives us 13d squared. And then right here in the middle we have minus 10, and we do not have another constant to combine that with, so we're going to bring down our minus 10. Our next problem is number 4. We have another set of parentheses that we're going to have to do the same thing that we did in problem number 3. We have to use the distributive property. So we're going to distribute this 5 to the 4. 5 times 4 gives us 20. Bring down our minus sign, and then we're going to distribute that 5 to 9d. So 5 times 9d is 45d. And we've got to bring down the rest of our expression, minus 2d squared. Okay. Now we look at our expression and we see there's no other constant. There's no other term with just the variable d. This one has a d, but it has a squared as the exponent. A 2 is the exponent. So none of these terms are alike, so we are finished with this one. We can't combine anything else. Problem number 5. We have 9r minus 7r plus 2r to the 4th. Okay, we take our first term, 9r, and we see that minus 7r has the same variable, and they have the same exponent because they both have an understood 1 as their exponent. So 9r minus 7r would give us 2r. And then we have plus 2r to the 4th, and we do not have another term that looks like that, so we're just going to bring that down. They both do have the same variable, but they do not have the same exponent, so we cannot combine those terms. They are not like terms. Okay. Number 6, we have another set of parentheses, so we have to distribute this 7 to what's inside the parentheses. So 7 times 8 gives us 56. We're going to bring down our minus. And then 7 times 2k gives us 14k. And then we have our minus 9. Now we have two constants. So we have our 56 and then our minus 9. Notice that the sign goes with the number that's after it. Okay, so 56 minus 9. And so what is 56 minus 9, Leanna?
47.
47. So we have 47 minus 14k because we do not have another term that matches that 14k. Right, number 7. We have a rather long expression, so let's start with our first term, 7k, and we have 6k that looks like it, so minus 6k. We have a k, but it's squared, so only 7k minus 6k, and that's going to leave us with, Lexi? With just k, exactly right. It's 1k, but our 1 is understood. All right, our next term is minus 4, and we do not have another constant, so we're just going to bring down our minus 4. And then we have our last term plus 9k squared, and there's not another term like that, so we're going to bring that one down. All right, number 8. We have 5k plus 8k plus 2 plus 3 minus 4k cubed. All right, let's start with this first term. 5k, and we have another term, 8k, and those are like terms. So what is 5k plus 8k, Emily?
13k.
13k. And then we have our constant 2, and we have another constant, plus 3. So what is 2 plus 3, Dayton? 5. So we're going to use our same plus sign because we have a plus here. So 2 plus 3 gives us 5. And then we have one more term, minus 4k cubed. Does not have a like term, so we're just going to bring that one down. Number 9. We have 4c plus 5c minus 9 minus c. Now, our first term is 4c. What else looks like 4c, Eli?
5c.
Okay, plus 5c. And what else? Dawson? Minus c. Good job. So we have 4c plus 5c, which gives us what? 9c, and so we have 9c minus c. What is that?
8c.
8c. Good. Can't forget about that 1 that comes before that c. Okay, that's its coefficient. And then we have minus 9 left. So 8c minus 9. And our last one, we have number 10. We have to use the distributive property. We're going to multiply 3 times 4k, and that gives us what, Ben? 12k. We're going to use our same sign, 8. And then we have 3 times 8, which gives us what, Yuri? 24. And we have our minus 6. Okay, so here we have 2 constants. So we have plus 24 minus 6. I'm going to go ahead and bring down my 12K because I know there's nothing else like it. And I know that it's going to be a plus after it. And so what is 24 minus 6? Let's see, Jamie? 18. So we have 12K plus 18. The biggest thing to remember in combining like terms is that it has to have the same variable with the same exponent. These two are not like terms because this one has a 1 as its exponent and this one has a 2.